This video is for class 9 physics, and in this video we are discussing about the greenhouse effect and global warming. Greenhouse effect. In 1824, Joseph Fourier discovered the greenhouse effect. It is the process of warming of planet's surface and its lower atmosphere by absorption of infrared radiations of long wavelength emitted out from the surface of the planet. Okay, now here few things need to be discussed. What are infrared radiations? Okay, these are the radiations or energy coming out from a hot source. So infrared radiations are the energy coming out from hot source. Okay, energy coming out from hot source. So this is energy coming out from any hot source. Okay, from any hot source. It can be sun, it can be light, it can be heated objects, any heated object. Okay, if your bulb gets heated, that can also emit infrared radiations. Now this infrared radiations, okay, have a variety of wavelengths. Okay, it has a range of wavelength. Now what is wavelength? If you remember, in class 7 we have discussed this wavelength in the chapter light energy. So any form of energy, any energy, right, it can travel in the form of wave, right, it can travel in the form of wave, right. So now this wave, particular wave, is the disturbance created in the medium, or is the disturbance created in any solid, liquid or gas, right. So wavelength is the distance between these two hills, you can say, or these two valleys, you can say. If you remember, the hills were named as the crest and the valleys were named as the trough. So wavelength is the distance between two consecutive crests or distance between two consecutive trough, right. So depending upon the source, the infrared radiations has a certain wavelength. Okay, so here the wavelength emitted out from the surface of the planet is supposed to be long, right. Why it will be long, we shall discuss it afterwards, right. That is trapped by the atmosphere, right. So that process is known as the greenhouse effect. So the solar radiations, again these are the energy, a kind of energy coming out from sun, have high energy radiations such as gamma rays, X-rays, ultraviolet rays and low energy radiation. So it has a range of radiations. Okay, who has range of radiations? Sun have range of radiations, right. High energy radiations and low energy radiations. Among the high energy radiations, gamma rays, X-rays and ultraviolet rays. So those who have high energy will have less wavelength. High energy will have less wavelength, right, less wavelength. Okay, so high energy will have less wavelength. So this all gamma rays, X-rays and ultraviolet rays are having less wavelength, and low energy radiations will have long wavelength. Let's see what are those, such as visible light, infrared radiations and radio waves. Our Earth's atmosphere is transparent only for visible light and infrared radiations of short wavelength. That means it allows only the visual light and the infrared radiations of shorter wavelength out of so many radiations. Like gamma rays, X-rays, ultraviolet rays are absorbed by the ozone layer surrounding the earth, while infrared radiations of long wavelengths and radio waves are reflected back into the space by the uppermost layer of the earth's atmosphere, that is the ionosphere and polar caps, as shown in the figure here, right. Here you can see longer wavelengths, like here you can see infrared radiations and this other longer wavelengths, radio waves, infrared radiations, they are reflected back. Okay, actually they come all together, but just for the simplicity they are been divided in these three sections, 1, 2 and 3, but they all come together, right? There is no sections. Now here you can see the longer wavelengths are reflected, okay, by ionosphere and the polar ice caps, etc. Okay, and it is transparent for this visible light and infrared radiations of short wavelengths. They can easily pass through the atmosphere like shown here. Okay, let us go to the next paragraph. The solar radiations which travel through the atmosphere of the earth are absorbed by the clouds, Earth's atmosphere and seawater, due to which the Earth's surface gets heated up. Now Earth's surface radiates infrared radiations of long wavelengths, as Earth is much colder than the sun. So whatever infrared it is radiating, that will have a long wavelength, okay, that will have long wavelength, that means less energy infrared radiations. Now for these radiations, the earth atmosphere is opaque, as it does not allow, right, to come in, hence it will not allow to the rays to go out also. So they are reflected back by the clouds and are absorbed by the gases present above the earth's surface. Thus the clouds and gases prevent the long wavelength infrared radiations from escaping into the space and keeps the earth's surface warm. Figure 6.13 shows the greenhouse effect. Here this one, as we were discussing about the rays, we had discussed this rays, we had discussed this rays also, right, and these are the longer wavelengths which are absorbed by the clouds. So when the earth is radiating infrared radiations of long wavelength, that will be also reflected back to the surface of the earth, because as here you can see they are reflected, okay. Similarly the atmosphere will reflect, it doesn't have to go to this level also, the clouds will reflect, right, and the atmosphere will reflect. So when they are reflected, now this heat will be absorbed by some gases present in the atmosphere, right. Now let us see what happens. The gases which are a good absorber of long wavelength infrared radiations are called greenhouse gases, okay. So these gases has the capability of observing the long wavelengths, right. So they are carbon dioxide, water vapors, methane and chlorofluorocarbons. These gases contribute in trapping the heat energy within the atmosphere. The naturally occurring greenhouse gases have an average warming effect of nearly 33 degrees Celsius, so that the average temperature on the earth's surface is about 15.5 degrees Celsius or 60 degree Fahrenheit. In absence of greenhouse gases in atmosphere, entire heat energy radiated from the earth's surface and the objects on it would escape out into the space, and then the average temperature on the earth would be minus 18 degrees Celsius or 0 degree Fahrenheit, instead of being 15.5 degrees Celsius or 60 degree Fahrenheit. So if the gases are not there, the earth will be at nearly minus 18 degrees Celsius, which is very cold, right. On the other hand, if there is an increase in the proportion of greenhouse gases in the atmosphere, the average temperature on the earth will rise and it will be above 15.5 degrees Celsius or 60 degree Fahrenheit. Okay, so we need to have a balance of this greenhouse gases in our atmosphere, right. So this is how the greenhouse effect takes place, okay. Now because of the increase in these greenhouse gases in our atmosphere, we are facing a problem known as global warming. In fact, global warming is not a problem, but excess of global warming is a problem. So let us go to global warming. We are doing only the definition part of global warming. So global warming means the increase in the average effective temperature, that was 15.5 degrees Celsius, right, increase in the average effective temperature near the earth's surface due to the increase in the amount of greenhouse gases in its atmosphere. So this is all about global warming. We are not doing in detail, okay, as your syllabus has been reduced. So this much for this video. Thank you so much.